So multiplying fractions. The basic concept of multiplying fractions is pretty simple. Essentially all you're going to be doing is multiplying numerator by numerator and then denominator by denominator. And that's about it. Yes, there's a couple of other steps that we'll have to do, and multiplication lends itself well to what's called cancellation, or canceling, okay? We're going to do some canceling. So let's get started. So right here I have 1/3 times 1/4. All we have to do is multiply numerator times numerator, so 1 times 1. That gives us 1. And then 3 times 4, which is 12. And it's 1/12, so 1/3 times 1/4 is 1/12. Not too bad, right? Of course, you always got to check to see if your fraction's proper. And 1/12 is proper. The numerator is smaller than the denominator. And is it in its lowest terms? And yeah, it's in its lowest terms. It can't be reduced anymore. Okay, so that's it. We're done. Piece of cake, right? Again, that's the basic concept of multiplying. It's just multiplying numerator times numerator, and that's it. Denominator times denominator, and that's it. Okay, let's do another one. Let me change it up a little bit and start getting into some that are a little bit different. All right, so what I'm going to do is I'm going to add a whole number to the first fraction. Okay, so now we have 1 1/3 times 1/4. Now what I tell my students is, if we're multiplying two amounts, two numbers, two quantities, and if one of those quantities just needs to have one of those quantities just needs to have a fraction, everything needs to be in fraction form. Or I can't, it's to say that I can't have the whole number here. I have to convert that whole number into an improper fraction. And then I can multiply numerator times numerator, denominator times denominator. So let's do that. So to convert the mixed number to an improper fraction, we're going to multiply and then add, okay? And the multiplication is this dot, okay, the point. So, going in this direction, 3 times 1 is 3, plus 1 is 4, and the same denominator, okay? Now I can bring this one down, and we can do the multiplication, okay? So 4 times 1 is 4. And 3 times, I should probably put my arrows right so you guys can see that. 3 times 4 is 12. Now I need to ask myself, is this fraction in its proper form? Yep. Numerator is smaller than the denominator, so yeah, it's proper. Is it in its lowest terms? No, it's not. 4/12, I'm going to go ahead and put it down here. 4/12 is not in its lowest terms, and you should be able to recognize that quickly just by seeing that both numbers are pairs, or I mean pairs, it's Spanish. Both numbers are evens. Okay, so if they're both evens, that means that you can at least divide both numbers by 2. And remember that reduction, or putting a fraction in its lowest terms, will be some sort of division. And I like to use my little box right here. So I know I'm going to divide both numbers by the same number, okay? So 4 divided by some number and 12 divided by some number has to be the same number. Now I could use 2, but that won't get me to the lowest term. I would actually have to do another reduction to get to the lowest term, so I'm not going to do that. I have a little bit of practice with my times tables, so I want you all to be practicing your times tables. And I'm going to go ahead and get to the end in one step. 4 divided by 4 is 1, and 12 divided by 4 is 3. Okay? So there it is, 1/3. I'm going to show the same problem one more time. This is where, remember the answer, it's 1/3, okay? This is where I was talking about cancellation. It's this tool that we use when we're multiplying fractions to make numbers smaller so they're easier to multiply, or also so we don't have so much reduction at the end, so we don't have to worry so much about the lowest terms. Always worry about it, but it's usually easier if we cancel first. Okay, so how does cancellation work? Well, canceling works by dividing. We're just going to be reducing a numerator and a denominator by the same number. We're going to be dividing a numerator and a denominator by the same number. Now, it doesn't have to be a numerator and a denominator from the same fraction. You can pick a numerator from a fraction over here and a denominator from a fraction over here. A number on top and a number on bottom. They can be from the same fraction, but they don't need to be. They can be different numbers. I was doing a vogue right there, huh? Anyway, so I'm looking at these four numbers. I'm looking at these four numbers, and I'm looking to see if there's one on top and one on bottom. Doesn't have to be from the same fraction. That can be divided by the same number. And I'm looking at the 4 and 4. Yeah, these two can be divided by the same number. In fact, they can be divided by themselves. So I'm going to divide this 4 by 4, and that gives me 1. Okay? And I'm going to divide the other 4 by the same 4, and that'll also give me 1. Now remember, it's important that you divide, or that you cancel these two, dividing by the same factor for both. Okay, very, very important. Okay, I said it. Now practice. So now we can do the multiplication. So 1 times 1 is 1, right? And then 3 times 1 is also 3. And that's the answer we had before, 1/3. Okay. Cool. All right. Let's do another one. I'm going to be doing about 2 or 3 more. Okay, so get comfy. So I'm going to leave the first one the way it is, and I'm just going to change the second one. Okay. Now, again, when you're multiplying two fractions, you can't have whole numbers. Okay. Or if you're multiplying two quantities, two amounts, and if one of them has a fraction, everything has to be in a fraction form. It doesn't matter. Got to put it in a fraction form. So we already did this one last time, so I'll just write that again, 4/3. And then this one is a multiplication and an addition. 4 times 2 is 8, plus 1 is 9. And same denominator, okay? Same denominator, doesn't change. So let's go ahead and try canceling first, okay? So remember, the rule is that it has to be a number on top and a number on bottom. That's it. They can be from the same fraction, or they can be from different fractions, okay? So what do you guys see? Well, we already did the 4s. We can do those ones again. So let's go ahead and do those. I'll do them in black here. Okay, so 4 and 4 are both going to be divided by the same 4. And 4 divided by 4 is 1. But this example has another cancellation that we can actually do. 3 and 9 can both be divided by what? By 3. So yeah, so let's go ahead and cancel these two guys out and divide both of them by the same 3. 3 divided by 3? 9 divided by what? 3. Again by 3, and that's going to give us 3. I just have students, I emphasize that a lot because I have students that want to divide this one by 3 and divide this one by 9. Don't do that. You got to divide both by the same number, okay? All right. So these are the numbers I'm going to multiply. 1 times 3 is 3. 1 times 1 is 1. Okay, and I'll just put my little arrow here so you can see that. Now, is my fraction proper? This one. No, it's not proper. No, the numerator is larger than the denominator. So what do? I need to divide. So to read, when you guys read a fraction like this, remember that this is a division. Fraction bar, that line right there means division. Something over something is division. When you read this, this reads 3 divided by 1. It does not read 1 divided by 3, okay? It's always a top-down kind of thing, okay? You're going to want to read it looking or going downward. So 3 divided by 1, okay? That is 3. And there's no remainder, so there's no fraction left over. There's no part of a next whole left over. So it's 3. That's it. 3 wholes. And that's it. Okay, I'm not going to do this one without canceling. I'm going to do one more problem, and I'll do it both ways. 1 time canceling and 1 time without canceling, okay? So I'm going to use these two fractions, and I'm just going to add a third. That's all I'm going to do, is add a third one right here. Okay. And I'm going to jump ahead. We already know what to do here, right? We can't have whole numbers. We got to turn them into improper fractions. Okay, so that's 4/3. Let's jump ahead here. We already did that one. That was 9/4. And then I added a third one, 1/6. Okay, I just dropped something here. Let me get that. I'm back. Okay, and we're going to cancel. We already know that we can cancel these guys. So let's go ahead and do that right off the bat. So we say 4 and 4 can both be divided by the same 4, which is 1. And 4 divided by 4 is 1. Excuse me. 3 and 9 can both be divided by 3. 3 divided by 3 is 1. 9 divided by 3 is 1. Okay, and I know, I'm sorry. No, it's not. Woo! That was a close one. Just making sure you guys are paying attention. 9 divided by 3 is 3. Okay, now we're good. This is pretty much where we were last time. But we have another fraction over here. Now, just because I used this 9 and I canceled the 9 one time and I got 3, doesn't mean that I can't use the 3 to cancel again. It just makes the number smaller. It makes less work for me later, right? Okay, so I'm looking at the 3 and the 6. These two can both be divided by 3. So let's do that now. 3 divided by 3 is 1. And 6 divided by 3 is 2. I got that one right this time. All right, so now my multiplication is going to be with these numbers. My reduced numbers, my canceled out number, my reduced numbers. So 1 times 1 times 1 is 1. 1 times 1 times 2 is 2. 1/2. Proper? Yes. Check. Lowest terms? Yeah. Also, check. So like I said, as promised, I'll do this one more time without canceling. Okay, so you can see the difference. All right, so this was 4/3. And 1/6. Okay, so it's kind of interesting because some students think it's easier just to reduce at the end. Maybe it is. If that was all we were doing when we cancel, it was just to reduce, and maybe just wait till the end to do it. But there's another reason why we like to reduce, or why I like to reduce, and that's because it sometimes makes the multiplication a little bit easier. Working with smaller numbers is always better. It makes you quicker. Lets you get to the answer a little bit more efficiently. So let's go ahead and multiply. 4 times 9, 36. Times 1 is 36. I'm running out of room, but I think you guys can see that. 3 times 4 is 12. 12 times 6, go. Did you get it? It's kind of hard, right? I mean, if you're not so familiar with your 12s, you might be like, oh, what is that? Counting on your fingers or something. But it's 72. Okay, and remember, we're just multiplying straight across. 3 times 4 is 12. 12 times 6, 72. Now, is the fraction proper? Yeah, it is. The numerator is smaller than the denominator. So we already have a check there, so I'll just erase that one. Is it in its lowest terms? No, it's not in its lowest terms. I'll rewrite it over here. Okay, and then I know that I need to reduce, so reduction is going to be a division. Now, I have students that are not so good at reduction, and it's because they're not so good at their times tables. So if this is difficult, or if you're slow at this, it's definitely your times tables. Get better. Okay, so what can you divide the two of them by? Well, I can divide both, just because they're even numbers, I can divide both of them by 2. But that's a small bite. I'm not taking very much out of it. I could use 4, right? It's a little bigger bite. I could use 6, I believe. Yes, I could use 6. I could use 12. And I can use 36. Again, the bigger the number, the quicker you get to the end. And if those big numbers are hard for you, practice your times tables. And I saved us work here. I know that most people would go by 2, by 2, by 2, by 2 until you get down to the end. And that's fine. But I'm just trying to show you that for me, when I cancel, the multiplication becomes easier. I never had to multiply to get to a number like 72 when we canceled. It was 1 times 1 times 1. That's 1. And then it was, what was it? what was it? It was 1 times 2, or it was 1 times 1 times 2. That's pretty easy to do, and then you're done. I don't know. You can pick the way you like. Good luck, okay?